In this episode, we're going to be talking about the trends and the chemistry of Group 2 elements. Hello, welcome back to the Chemistry Made Simple podcast. If we haven't met before, I'm your host, Matthew Macario. I'm a coach, tutor, and mentor for chemistry students just like you. My aim is to use this podcast and lots more besides to help you to get from point A to grade A. Now, with no more delay, let's get on with this episode. Hello, welcome back to the podcast. In this episode, we're going to be talking about the chemistry of Group 2 elements, the Group 2 metals, and we'll be talking about physical trends within that Group 2. So first of all, what do we mean by Group 2? Well, on the periodic table, a group is a column down the periodic table, and Group 2 is here. So you'll be able to see that Group 2 are metals, and they're often referred to as the alkaline earth metals or alkaline earth elements. If we zoom in, we can see Group 2 begins with beryllium, works down to magnesium, calcium, strontium, barium and radium, and we'll be looking at this group more closely. We won't be looking at beryllium though, and we won't be looking at radium. We'll be looking at the chemistry and trends from magnesium down to barium. We don't study beryllium when we're looking at these Group 2 trends because it's quite atypical. It doesn't really fit in with the rest of the trends, so there's no point us trying to match it with those trends. We don't study radium, it's not part of the A-level syllabus. Although it does fit the trends that we're going to be talking about, radium is an element that's more of interest for its radioactive characteristics, and therefore we're going to leave it out at this point. So we're going to look at the Group 2 elements from period 3, magnesium, period 4 calcium, period 5 strontium, and period 6 barium, and compare some of their physical properties and the chemistry of some of their compounds too. So what are we going to talk about today? What are you going to learn? We're going to talk about physical properties of those Group 2 elements. We're going to talk about some trends in those properties, and we're going to talk about chemical reactions of Group 2 and some trends there as well. And we'll talk about real-world applications of some of these too. The first physical property we're going to talk about is the electron arrangement of the electrons in the outer shells of the atoms of Group 2 metals. And because it's Group 2, there are 2 electrons in that outer shell, in that valence shell. And those electrons are both in the s orbital. They fill the s orbital of that outer shell. For example, with magnesium, those outer shell electrons are in 3s2, and with calcium in 4s2, and so on. So we'll look at the trends in the atomic radii. The atomic radii increase down the group. Hopefully that's not too big a shock. And the reason is because each successive element going down the group has an extra shell of electrons, an extra energy level that has electrons in it. So those electrons are further from the nucleus. And yes, as we go down the group, the nucleus does have a bigger charge, but there's also additional shielding because there's an extra full shell of electrons between the outer shell and the nucleus. Melting points. Well, these are all metals, so as you would expect, their melting points are relatively high. They have that giant metallic lattice structure. It takes a lot of energy to overcome that, to break down the attractions that are there holding that structure together. The melting points do decrease down the group slightly, and that is because the outer shell electrons in that sea of electrons are further from those nuclei that they're attracted to. So there is, as we go down the group, slightly lower attraction and therefore slightly less energy required to melt those metals. Now there is an exception. Magnesium actually has the lowest melting point of these 4. The reasons are not straightforward. You're just expected to remember that magnesium is the exception. It has the lowest melting point. You don't need to learn or remember the reason why. Now we're going to look at the trend in ionization energies, and it's important to remember that Group 2 metals only form 2+ ions. They don't form any other ions. So when we're looking at the ionization energy, we're looking at the total of the first and second ionization energies. So that's the amount of energy that was required to turn a mole of gaseous atoms into a mole of gaseous 1+ ions, and then adding the second ionization energy to it, the amount of energy it takes to turn a mole of M+ gaseous ions into M2+ gaseous ions. And that total decreases down the group, and that's simply because, again, the outer electrons are further from the nuclei. Therefore, they have less attraction to that positive nucleus, and it's easier, takes less energy to remove those electrons. Okay, time to start thinking about the chemical reactions of group 2. So we're going to start with the reaction with water, and the reactivity with water increases down the group. The reaction is a redox reaction. The metal reacts with water to give a metal hydroxide and hydrogen gas. So the metal is being oxidized, it's losing electrons, and the hydrogen in the water is being reduced to elemental hydrogen. Magnesium does do this reaction, but it's very, very slow in cold water. And that's an important thing for you to remember. It will be something that you're very likely to get questioned about in an exam question. Calcium, strontium, barium react progressively more vigorously as we go down the group. So calcium does react with cold water more than magnesium, strontium and barium more vigorously again. Now magnesium does react more quickly with steam than it does with cold water, but it gives a different product, and that's really important because you're likely to be asked about that when you're asked about magnesium with cold water and magnesium reacting with steam, and you'll be expected to understand that they give different products as well as reacting at different rates. When magnesium reacts with steam, you still get a redox reaction, but you get magnesium oxide and hydrogen as the products, not magnesium hydroxide. The next trend we're going to look at is the solubility of the group 2's hydroxides, and this increases down the group. If we start with magnesium at the top of this column, magnesium hydroxide is almost insoluble. Calcium hydroxide is described as sparingly soluble. It is a little bit more soluble than magnesium hydroxide. Strontium hydroxide is more soluble, and then barium hydroxide is very soluble. Compare that with the solubility of the sulfates. Now this decreases down the group, so it's the opposite trend to the hydroxides. And again, this is something that will likely be asked about in exams. It's important to remember that sulfates and hydroxides have the opposite trend, but also which trend is which. Solubility of sulfates decreases down the group. Starting at the top, magnesium sulfate is very soluble. It's used in bath salts. Hydrated magnesium sulfate is Epsom salts, so you may have used that. Maybe you at home or someone in your family is using Epsom salts as a bath salt. Going down the group, they get decreasingly soluble such that actually barium sulfate is virtually insoluble. Okay, and this brings us to talk about the applications of some of the group 2 metals and their compounds. Remember these are important to know because they will come up in your exam questions, and I'll go into more details of them elsewhere. But it's important to know magnesium is used in the extraction of titanium from titanium ore. Titanium is a really, really useful metal. It has a lot of very useful properties, but it's not easy to extract from its ore. And we use elemental magnesium, solid magnesium in that process. Calcium hydroxide, if you remember a couple of slides ago, we talked about calcium hydroxide being sparingly soluble. It's often used in agriculture. It's spread onto soils that are more acidic than is required for what is going to be grown. And because it's sparingly soluble, it will only slowly be leached into the soil, which is exactly what is required. You won't get sudden changes. Now, magnesium hydroxide and barium sulfate have applications in medicine, very different applications from each other. And if you remember, both of these are very insoluble. Magnesium hydroxide is sometimes called milk of magnesia, and a suspension of magnesium hydroxide is still used as an indigestion remedy. Barium sulfate is also very insoluble, but it has a very different application. This is used as a barium meal. It's given to patients to enable X-ray of their gut to see where there may be blockages, leakages, or so on. Barium, being a heavy metal, is very opaque to X-rays, so it's a good way of seeing where the barium is getting to and not getting to. Now, if you're a member of my membership, I go into a lot more detail of these applications there. And I would advise you to learn those anyway. Make sure you know the details of those applications because they come up in questions and exams on a frequent basis. And you're expected to not just know the applications, but be able to write the balanced equations for what's going on too. Okay, quick summary of what we've talked about today. We've talked about what group 2 metals are. We've said that we're talking about magnesium down to barium when we study the group 2 metals. There are other group 2 metals, but those are the 4 that we look at when we're talking about the trends. We talked about the electronic structure. We talked about the trend in the size of the atoms. We talked about the trend in the ionization energies. We talked about the type of ions that group 2 elements can make. And then we talked about the chemistry. We talked about the reactions of the elements with water, cold water and hot water. We talked about the products that you get from those. We talked about the trend in the solubility of the hydroxides. And we talked about the trend in the solubility of the sulfates of group 2 elements. If you have any more questions or you want to talk more about those applications of the group 2 compounds and metals, please drop a comment below and I'll get back to you. That brings this episode to an end. I wanted to take this opportunity to thank you if you're one of my Patreon supporters. Really appreciate your support, your financial support that's helping keep this podcast going for everyone. If you're not a Patreon supporter yet and you'd like to be, then please go to patreon.com/chemistrymadesimple. That's also a great way to contact me if you have any questions about anything I've talked about in this or other episodes, or you've got suggestions for something else to cover in an upcoming episode too. Other ways of contacting me, a good way is Instagram. You can find me there at Chemistry Made Simple. You can contact me by email. That's matthew@chemistrymadesimple.net. Or you can drop me a short voicemail. That's at chemistrymadesimple.net/voice note. And if you're interested in joining the membership that I talked about, and why wouldn't you be, then go to the link chemistrymadesimple.net/program. I look forward to seeing you there and really helping you get that A grade. Make sure you're subscribed to the channel and you've liked this episode, because I'm looking forward to seeing you again at the next one. Till then, do look after yourself and goodbye.